Okay. All right, so here we go. I had asked you to take a look at this, so hopefully there are parts that we don't have to belabor. Some of it is a little bit of a review from before, so I won't focus on that too much. Okay. So we've talked about what Java EE is, kind of where it came from. The important thing is it's an enterprise information systems platform, so it's designed for large-scale applications. Java EE, that ability to build things using Java wasn't part of the original Java specs. That arose later on. It's part of a set of specifications, a managed environment that is now up to version 7. So it's been since 1998, I think. So it's made a lot of progress over time. There's a history, if you come from the web development world, there was a history where people liked the idea in the beginning, but they hated the implementation, so there was a lot of backlash against that. Things like Spring, for example, arose because of some of the problems that the early versions of Java EE had. But you'll find nowadays that Java EE is at least as high performance, if not more, than almost anything I can think of. And is in fact, I've seen examples of it being used for what is called microservices architecture, where you'd have a front end that uses something like Angular, and the back end, instead of using Node.js, you could use Java EE, and your microservices would be web services that you build out of EJBs. And it actually has been shown, if you're interested in that sort of thing, and where it's gone, there's a fellow named Adam Bien, B-I-E-N. He's a German developer who's extremely well known in the Java world, the Java EE world, and he has a running weblog on all kinds of Java-related things and Java EE things. And if you're really interested in seeing how it can be used today and how it stacks up against some of these other architectures, you can take a look at what he's been saying. So the idea behind it is a managed model that the design and implementation, the life cycle is managed, the idea of embedding transactions and security, and deployment is a standard thing also. The idea is that if you buy into it, then you adhere to that managed model. We've used this term before, the idea of containers. Containers are the infrastructure that supports these different features that you have, request handling, the transaction management, the object relational mapping, all those things are part of the environment. And containers inside this model are the pieces of the server, they're not necessarily on the server only, but there are pieces of the architecture that actually handle components of the Java EE spec. Okay. Of course, relies on Java. Okay. So here's a picture that shows that. Is that you'd have underlying these would be any of a number of operating systems. Then you'd have the platform-independent Java sitting on top of that, the Java EE app server, like the Glassfish or JBoss or Wildfly or WebLogic or any of those, which then has the support for the API. Then the APIs are exposed to your application, and then you write to those APIs, and the rest of it is handled for you. So that's, again, the basic idea. There are two primary types of applications. There are web applications and EJB applications that run on the server side. Now, in fact, you may remember the way I originally described this, I said there were really 4 different kinds of containers. There's the one that runs inside the browser for Java applets. That's being deprecated. Okay, so that's why you'll notice that's the most recent versions of the browsers like Chrome don't support Java applets anymore. The reason for that mostly had to do with security issues. Okay? But that is still there. I mean, you can find browsers that will support that still. Then there is also the capability of essentially embedding the Java EE spec or parts of it into your own well, not standalone, but a non-web application. Okay? So if you wanted to write an application that talked to a Java EE server, you could do that on a peer-to-peer basis or client-to-server basis, so that you could have EJBs running inside your application, which then can talk to components on the server too. So some people do that. But what we're talking about really is mostly things that are web applications, and then the EJB applications which are running on the server, okay, which the web applications then interface with. In terms of where they run, the logical separation on the server side is between the web container, which is the part that handles things like the servlets, JSPs, JSF, and then the EJB container, which essentially sits behind that, and then, of course, interfaces with it in our case. But that is actually considered a separate container in the spec. Okay? If it's going to be a real application server, it has to support both of those things. In fact, that's why if you you look at which are the biggest web servers and application servers that are out there, one of the ones that you're going to hear all the time is Tomcat. Okay, and Tomcat is essentially it's a Java EE compliant server, but it doesn't. It only supports a subset of the full specification. Mostly what is living over here, okay, in this web part, and not all of it even. But which is why you can run JSPs, servlets, etc., and even JSF inside of a Tomcat environment. Okay. But if you want the whole shebang, then you've got to go to a full-blown EE server. There are a number of open source ones. There's even, in fact, a Tomcat EE server that people are doing serious development. If you happen to like Tomcat, I mean, it's very fast, and people use it for a lot of real serious applications. So some people have gotten together and decided to flesh it out so it becomes a real full-blown EE server. But this will show the basic dichotomy between them. These are the four that I was talking about: the applets, the client side, the web container, and the EJB. But they can all connect to each other. One term you'll run across is this RMI IIOP. That's the mechanism for doing remote invocations. So it allows you from one Java environment to another, two different JVMs, to be able to talk to each other. Okay, that's the mechanism. So when you talk about serialization, for example, the reason that exists or existed in the beginning was so that you could take an object on one JVM, write it out in a textual format. That's what serialize means. Send it across the wire. Okay, you could even email it if you wanted to. And then on the other side, you would do the opposite. You would take that serialized version and then turn it back into a binary object. Okay? And that's what these things are supporting. So that's the basic underlying mechanism for that. So we've talked about this, most of this stuff, I think. Messaging here, but just to make sure you understand, we're not talking about this kind of messaging. Messaging means, well, I'll show you a little example of it. I'm not going to really get into the full JMS specification, though it's a very powerful thing if you want to use it. But that's the kind of messaging we're talking about, what's called publish and subscribe, or point-to-point messaging. That's more the idea of like transactional messaging. In other words, I want something done, or I want some information to be made known, and I can put it in a queue somewhere. And then anybody who's interested, might simply, I think in some of the applications I've seen, the texts, like for sending emails. The idea is that your application, it writes, you have your customer, they buy stuff, you charge their credit card and all that, and then you say, okay, it's going to be shipped. And then, of course, then they're gone. So you've got this request. So you want to send them an email confirmation. What you can do is your code could put a request for an email to be sent onto some message queue. And then some other things, asynchronously, will sit there and every so often go look. It could be notified immediately, but it could wake up every hour or whatever, and then pull things off the queue. That's what is meant by this. Okay, so in the web containers, we're talking about most of the stuff that you would find in Tomcat. Servlets, which is underlying most of what we're doing. It's the mechanism that actually allows you to get requests and generate HTTP responses. JSP is based on that. JSF is based on that too. The idea of filters and listeners, this is something that allows you, for example, filters allow you to take the requests that are coming in and then send them through various pieces of code that do various things. Okay? You could use a filter to check for security. Okay? So you'd never let the response be generated, or you wouldn't let them get to a piece of your application because the filter would have stopped it and then sent it on right back to them with a unauthorized response code or something like that. Servlet listeners, this allows you to listen for events like a session being created or a session being destroyed. Okay, so there's a whole bunch of those things, or requests coming in, and then there are other services you have access to. The EJB container is the other part. This is where all of these transactional things happen, where the entities are managed, where the beans are managed, the session beans, and where all of the rest of these things, where the JMS, the messaging I was talking about, security, the web service handlers, the SOAP-based and RESTful ones, and other things live in this container. Okay. So the reason, again, for this being created in the first place is because people who wanted to use Java to do web applications had to constantly, when they needed any of those kinds of services, before this existed, everybody had to write their own. So if you wanted a transaction handler, you had to go find one or write one. If you wanted a message handler, you had to find one or write one, et cetera, et cetera. So the idea was to provide the specification, so if you ever needed one, you could simply go to a compliant server and you know it was there, and it would have a standardized interface. So that's the major reason why this exists. Okay. And those you sometimes hear this term middle tier services. That's the kind of plumbing that everybody had to build for themselves that you really don't want to have to do for every application. So what the heck is this EJB? First of all, it's a poor choice of name, I think, because I think, as I went over once before, the term JavaBean has been so heavily overused and meant different things in different contexts that it's confusing. But we're not talking about the manage beans in this case. We're not talking about the user interface beans, which is where this term originally came from. There was an idea that you could, generate an icon which had code attached to it, and then you would drag and drop, code essentially, and connect them together. That was the original meaning behind the term. I've honestly never seen anybody really use that way. So, but there's also, in case you get confused, if you go and look in the Java APIs, you'll find a JavaBean API. That's what that's talking about, okay? Which is very confusing if you've only known the word JavaBean used like this. You say, well, what the heck is that? That is for that other interface thing. So don't get confused. So what is it really? It's a reusable component. The idea is that it is a Java object that's designed primarily to encapsulate business logic, okay? And to wrapper data for you. And that's the way I would expect you to use them. And it, in fact, is the way you've seen them used in all the examples that you've had to handle so far. And lastly, this thing is the thing that gets managed and executed inside of that special EJB container. How did we get to be here? We're essentially up to version 3.2, but the big change was at 3 and 3.1. Okay, there was a lot of again, historically, it depends whom you speak to and how long ago they got ticked off at Java EE. If they tried it 10 or 15 years ago, they might still be holding a grudge because it was a lot more clumsy to work with. It forced you to do a lot more upfront stuff, developing interfaces, and then you had to implement all those interfaces, and a lot of inheritance stuff, and a lot of it was XML based. Okay, you had to have these separate configuration files, and everything had to match up. So that ticked off a lot of people. That's essentially where Spring came from in the first place, was people getting upset at that. Well, ever since version 3, which goes back several years by now, things have gotten much easier, much, much easier. So in fact, you can still do things the old way, by and large, if you need to support older code or whatever. But with the advent of 3.0, you could start to use annotations, the @ annotations, right in the code. So then you move ahead, but you still needed to write classes, interfaces, which your classes would implement. Not that that's necessarily a bad thing, but again, it was a lot worse earlier on because there was a lot more junk that you had to do. Nowadays, as you'll see, I would recommend that you still write an interface and then implement it. But the amount of coding you do for the interface, if you've got 10 methods, is probably this big. Okay, and there actually is a good reason to use it, but that's not what I'm talking about. It used to be much worse than that. There was a lot of stuff you had to do. Nowadays, with 3.1, really that's the big change. You don't even need the class interface anymore. If you simply want to bean an EJB, you can simply say, @stateless or @stateful, and you don't have to define it in an XML file. You can. You don't have to define an interface for it. You can simply use it. Okay. That makes it infinitely easier. So it's most of the problems I think people had with it should be gone as far as that's concerned. So again, the @ annotation, so you didn't have to use the external files, which, as I said, ticked a lot of people off. You now have event listeners and callback methods supported by Java EE. The same kind of thing I was talking about with the servlets. You now have that same thing, as I'll show you, inside the EJB processing too. You have interceptors. If you remember, I talked about this a little bit. Remember I said how do you remember the term aspect-oriented programming? I mentioned that, AOP. And I said, basically, if you had all of these different functions, here's your credit card processor, your login function, your the shopping cart functionality. The idea is if you wanted to do, let's say, logging of all of those things, it would be, before this, you would have to write code in every single one of those to support logging in every single one. Okay, even if the logging was essentially nothing more than entering this class, this method, exiting this method. So what aspect-oriented programming says that, again, if you look at it as all of those things are kind of horizontal, or no, actually, I guess they call those vertical. If you remember the picture, each of those things would be a vertical function. Login and shopping cart, etc. Then what you have is this. The term is orthogonal, which means it's perpendicular to. Okay, so orthogonal means it goes this way, it cuts across all of them. And matter of fact, that's a term you'll hear is cross-cutting concerns, and that's now part of Java EE too. And one of my favorite things is this idea of dependency injection. Okay, now you should, I think, have a better idea now that you've actually had to do it a little bit. of what that means. And the real reason that that's important has to do with this idea of decoupling and making different pieces of code more separable from each other, okay? If you didn't have dependency injection, that means you would have to, in your own code, call constructors. You'd have to know exactly which constructor to call, all of the parameters it needs, etc., which is the way you used to have to do things. But that, in a large system, starts to create problems, okay? Because then you can have two different groups, each of which is responsible for two completely separate things, and every time that they have to touch each other, they'd have to confer closely as to figure out exactly what are you looking for, how do you do it, blah, blah, blah. So this idea of dependency injection and decoupling says that I need one of these things, you wrote it, you provided it, I use it. And essentially that's when you say @inject, when you say @EJB, that's actually what it's doing. And then the whole point is that all of the stuff that you need to have done before is now taken care of for you, as long as you stick with the APIs and the environment. And that was obviously true of JPA too. Okay, so no interfaces are mandatory. You added Singleton session beans. Those didn't exist before. You can now have stateful session beans. We'll talk about what the three different things mean again, or four different kinds of beans. The web service endpoints have to do with that microservice kind of architecture I was talking about, where you simply, there's a call made, you get a response. Call made, you get a response. Now they've extended it. It used to be that you could only do that with stateless beans. In other words, where there was no conversation. Actually, now you can, if you want to, do it with stateful ones too. There's a lot of other stuff in here that have to do with scheduling and timers. You have the capability of running code, once a week, on Thursdays at 3 in the morning, whatever, or doing batch processing. There are lots of other specs in here that we're not really touching but are available. And the idea of application profiles. If you don't need all of these features, you can have, for example, what's called a light web profile. That is, it's a compliant EE server, but if you don't need messaging, you don't have to load it. Okay, that's what that's talking about. So here are the clients again. You can have servers on this side, and they don't even have to be Java servers. They can call functionality over there. The desktop, this would be, as I was describing, for example, a container that runs in there. Browser, those are the applets. Again, we're phasing those out. The web container is more or less like what Tomcat gives you. The EJB container, and plus this is what the Glassfish would give you. And that's where some of these other functions live. And then oftentimes you'll see this as a 4-tier kind of architecture, is that almost every system you talk to has to talk to something else. Whether it's somebody else's credit card processing system, some other department's databases, etc. Okay? And so that is usually front-ended by EJBs somehow. Okay, so what do? They basically, nowadays, give you database abstraction. That's the entity, the JPA component does that. And then reusability, again, that's important because you don't want to have to write the same thing over and over again. There's workflows built into this. And then the implementation, of course, can be hosted on any system. You could have, one IBM mainframe running a JVM, and then talking to a Dell, a rack of Dell processors or something like that, running Windows, running another JVM, and as far as your application is concerned, you don't care. Okay. if you're interested in looking at the Java docs for this stuff, you can actually look in that package for the EJB specs. So there are three main categories in there: the session bean API, the message API, message-driven part, and then the persistence part, which is it used to be, and this, if you look at some older documentation, so if you have an older book and you're reading it and they talk about entity beans, beware, because that means that's the previous, pre-version 3 way that entity, what you learned as JPAs is the modern way of doing that. But there used to be entity beans which were on the same level as session beans, but that doesn't exist anymore. Okay, so we use JPA instead. So how are they programmed? As I said, it used to be that you had to use a class interface and an implementation. Nowadays, you can get away with just using annotations. And the interfaces are optional. But you'll find in a lot of examples, people still use them, and it's mostly for clarity. If you have several different versions of beans, as we'll see later on, you might have what's called a local bean versus a remote bean. It would make sense to have a class interface that you could then implement. So, because a lot of it would be the same, but there would be some distinctions. So it would make it clear how they're related, but still make it easy to make them different. Okay, so session beans. They're, as I said, business logic components. They're reusable. They can be used to manage state across interactions. The stateful ones can. And so there are three different kinds. Stateless, there's no client state. Stateful, that's conversational state. So what I mean by that is between requests, HTTP requests, the thing will stay alive, okay, as long as you need it. Versus this one is you get it once, use it, and throw it away, or throw it back. Is a better way of saying that. And then singletons are you essentially everybody or all parts of your application, and of course all your users, then essentially share a single instantiation across the entire application. So we'll talk about when you use each of these. Okay, so a stateless bean doesn't maintain that conversation. Basically, when the client code invokes it, the bean is created if it needs to be. Otherwise, it's pulled from a pool of pre-created beans. And it only lasts, in terms of, from the client's point of view, it only lasts for the duration of the method. Okay? Any specific variable instance values are lost as soon as the client's finished with it. Okay, so they're not available to anything else or that client either. There is a scope. We've talked about the other ones: request scope, view scope, conversational scope, blah blah blah. Here's one that you probably haven't seen: @ dependent. And that's essentially, it's a default for this, which is why you don't normally see it unless you have to override it somewhere. It means, literally, this is the kind of definition of what these are. It exists to serve exactly one client and has the same life cycle as that client. Okay, so they come and go as the client comes and goes. Important concept: all instances of a particular stateless bean are equivalent. If you have 100,000 users and they're all using a particular type of bean, stateless bean, you can't tell one from the other, or it doesn't make any difference which one any particular user gets. Okay, the container will handle that for you. Okay, because they can do this, they are essentially they can be pooled. Okay, we've talked about the term pooling before, and that idea is used a lot in different things. We talked about it in terms of database connection pooling, right? Okay, you remember? But that same idea can be applied to this, okay? As the server, and you can actually look in your Glassfish server configurations, you can, and you can change it too. If you go into the administrator, you remember the tool where you define the JDBC stuff?
Yeah.
If you look in there, you can also define this, okay? Which is how many instances of stateless beans do you want to keep around at any particular time? And that's a tuning thing that you use if you've got a lot of usage of a particular bean, then probably you want to maintain a fair number of them so that they don't have to be created that often. As soon as they're used and let go, then instead of being destroyed and have to be recreated, they essentially go back into the pool and get reinitialized each time they're needed. Well, that's actually not true anymore. That's what I said before. Usually speaking, in terms of these web services, the idea of web service usually responds to a single command, like get, put, post. Up until what I just said before, which is pretty recent, stateless beans were, and probably this is what you still do most of the time, implement a web service, but you actually can, so that's a little outdated. All right, so when do you use these things? If only one client has access to a bean at any given time, okay? So, if you're doing transactional stuff, updating a database or something like that, where you need to get in there, do a find, do a persist, merge, those things. That's that client talking to that database bean, and nobody else should be, right? It doesn't make any sense to share that because that's very specific to that client. But as soon as it's finished with that method, assuming either way, whether it succeeded and committed or failed and rolled back, the bean, you don't need it anymore, and so it goes back into the pool and gets reinitialized. Okay, so by definition, stateless means the state is not kept around. The bean can represent a web service, that's commonly, as I just said. If you're concerned about performance, this is extremely high performing this way because of the pooling concept, which again is why some of the more recent Java EE writings that I've come across have to do with these microservices, which is one of those buzzwords that you run into now. And they can be extremely high performance and suit that very well. There's no distinction, okay, between a particular one interaction from the next, so stateless makes sense. Normally speaking, you're doing synchronous calls. That is, if you do something and in your method and you wait on the response, okay? However, there are times when you might want to say, if something you expect to take a relatively long time, you could also, there's a slightly different API that you use to say, okay, this is an asynchronous call. Essentially, I'll be back later to check, or let me know when it's finished. Okay? That's a little rarer and you probably wouldn't use that in your code because there's nothing that you're doing that would be like that. But in fact, you can if you have to. Okay, number 2, what's a stateful bean? Obviously, from the name, the persistence actually is important in this case. So the state that they're talking about is what is called conversational state. That is the conversation, like the whole problem that we've been trying to solve with HTTP from the very beginning, because it doesn't support conversations. So this is essentially one way of approaching that. It's not shared. Okay, the stateless ones are essentially shared. They all look the same. They come out of the same pool. They're not shared while they're being used. Okay, but they are shared in terms of being, given up and then requested and sent back when they're not needed anymore. But a stateful bean, because it has persistence and conversational state, obviously it's talking about a particular client, and that's what you're trying to maintain. And probably the easiest way to think of this is the shopping cart, you know, kind of, or something like that. You have to, between each of the requests, you have to maintain something somewhere, somehow, either on the client side somehow or on the server side somehow. You know, where are you in the process? Okay. When the client terminates, the bean appears to terminate. Okay. It's actually, what goes on underneath the covers you really don't need to care about most of the time. But the point is, it's no longer associated with the client. Eventually, it will get destroyed if it's not needed anymore. And the client state is retained only for that session. When do you use these? If it's an interaction, that's the conversation. If it needs to hold client data across those interactions, like the shopping cart. If the bean acts as what you would call a mediator to other beans, so that you might need to, while those other beans are being used, this thing has to stay alive in order to act as that mediator between the client and those other beans. If you, this is something I didn't mention before, obviously, if you have to make sure that your methods are thread safe, then you have to do something special. In the case of the first of the stateless beans, there's no concept of that because it's one client, one bean. Here, there is, especially if you're acting like this, it is conceivable that you might have some conflicts that you have to manage. That's where the thread safe, these synchronizing might have to come into play. Okay, the third kind. What's a singleton bean? It's instantiated once for the whole application. Okay, so it obviously is used for a very particular set of things. It's concurrently accessed by all the clients, and so it's not in a pool. There's just one of them, and they can respond to any client. Okay, so generally speaking, there's very little writing one does to these things. They're mostly used for shared reading. Okay, so I mean, examples that come to my mind right away are things in your application like the list of countries, list of states, provinces. Those common kinds of read-only data structures that you might use all over your applications. Those are perfect for singleton beans, okay? Because that will give you extremely good performance and very little overhead for maintaining them, okay? And the only time that they die is if the application is shut down or the server crashed for some reason. You can also use these for web service endpoints, okay, like RESTful ones too, okay? But those would probably be, again, something like a GET in microservice terminology. Because you typically wouldn't be attempting to update one of these things, but you might be asking for information from it. So when do you use these? When you want only a single instance, okay? If you want to maintain consistency across all the clients, so you know that if it is used by one, the same information is used by all. And basically that's the concurrency that you get for free if you use one of these things. So here's a little matrix to make it a little easier to remember what's going on. One thing I haven't talked about yet is this remote versus local. Again, all that's talking about is whether you're in the same JVM or in two different ones, no matter where they are or anywhere in the world. They can be on the same machine, they could be on two different machines, they could be on two different machines on two different continents. It doesn't make any difference. But that's what that's talking about. So obviously all three kinds support all of those. Concurrency, well, that makes sense for Singleton. We just said that. This is unique, that's stateful. And the instances, how are they actually maintained by the EJB container? Pooled one-to-one between server and client, and many-to-one. Okay. So, now this is the fourth type of bean, EJB, that exists, which is the message-driven bean. And I'll talk about this just a little bit. I'm not going to get into exactly how it works beyond this description, but I think you'll get the idea. If you want to use this for something in your application, that would be great, but I'm not expecting you to. So they're kind of like workflow components using this queuing scheme. Okay. There's no client-oriented state, so it's like stateless. There's no distinction across the clients or beans. So that's the pooled idea for MDBs. But they're also different. There's no direct client access. There's no way you get at them directly. Actually, that's sort of true with the other ones too. But this is really true. You access them through the JMS API. So you're not creating them yourself. You're asking JMS to create them for you. And they're basically asynchronous. This is kind of the opposite of what I was saying before. Usually your method calls are synchronous. You do something and then you wait till the response comes back. This is more the opposite. You do something and you don't care. Eventually you might get a response back, but it could take, it's more like, instead of talking on the telephone, that's a synchronous thing. You're talking and you expect somebody to talk back to you in real time, right? That's more like synchronous. Asynchronous is more like texting. You might text somebody and they may be there, but they may not be, okay? But they get the message, and eventually, so that's their message queue. In other words, that model is essentially what we're talking about. You are putting something into their message queue, eventually they will pick it out of the message queue and respond to it, at which point you'll get a notification back. That's what this kind of thing provides for you. So, a couple of terms that you run up against. A JMS provider is the messaging system that's built into the container. The clients are, if you use the APIs that produce and consume the messages. Messages are those objects that are created that go back and forth between the clients and the queues. You also have a couple of other concepts, administered objects you'll run up against. And then it supports two different models of interaction. One is called point-to-point, and the other is called publish and subscribe. So if you have an application that needs something like one of these two, then you might consider using using JMS. In this case, in the point-to-point, what happens is basically what I just said, with your texting idea. Each message is addressed to a specific queue. You create the queues beforehand, and then you ask for the message to be placed in the queue. Then something else, some other client is the receiver, and it will occasionally, or however it wants to do it, will go and look in the queues and say, give me the next message to process. And then there's also transaction capability built into those things. There's the idea of you're making sure if the system goes down that the queue isn't lost, things like that. That's built into there. There's expiration. You can say this message is good until then. After that, if I don't get a response, it's useless to me. So just let it go. Things like that. So that's the most obvious. There's also another type, which is called publish and subscribe. And the idea there is slightly different. This is more like, not logically speaking, this is more like reading news feeds, okay? That you have a portal or something like that. You have an RSS reader, you know what I'm talking about? Atom feeds, RSS, that sort of thing. And you essentially are subscribing, if you want to read the New York Times feed or the Yahoo feed or NPR or something like that, you're essentially subscribing to that feed. It is doing publishing. And so that's the concept here. In other words, you can, instead of this being kind of a one-to-one sort of deal, here, this is more like a one-to-many, okay? So that you can have multiple clients, all of whom are listening for particular, like news feeds, to use that analogy. And then they can, all of them will see it, okay? And then they'll process them. If one wants to look at it, it won't be eliminated until everybody who was interested in it has a chance to see it. Okay, so it's a different kind of model. And maybe you've got something that makes sense for that. Okay, that's the extent of my introduction to JMS. It's actually a very powerful thing if you have a necessity for that kind of processing. I'll just quickly go over this since you have been beaten over the head with JPA. This is again, these are not beans anymore, but they are part of EJB as the specification. JPA is now what the entity beans used to be. Automatic persistence, essentially learned from Hibernate. That's one of the reasons the entity beans are dying off, because people came up with a better model, basically the Hibernate model, which is now fed into what we know as JPA. So there are different implementations of JPA, Hibernate being one of them, Eclipse Link, which is the one that you're using by default, and then there are other ones too. So persistence, remember we talked about container managed versus bean managed or application managed. This is where you essentially let the container do everything. You don't have to handle the transactions yourself. But the problem is you can only have one transaction per method. If you need something more complex than that, then you might have to go this way. So if you can have you say start the transaction, do this stuff, check for exceptions, roll it back, and then you might do another one like that inside of your methods. So that's where you have to go into this style. The annotations you recognize. These are the ones for the 3 session beans. Message driven is the one for that bean. And of course, these guys you recognize from JPA. Now, these are the 3 different, I guess they call them access modes, that I was talking about before. There's actually another one called local bean. But local, what this is talking about is where is the other thing that I'm talking to, where does it reside? If you say it's local, that means they're both within the same JVM. If it's remote, it means the other one is someplace else. It could be on the same one, but the remote will say, if it's not there, go find it. And it could live in a different JVM someplace else. And then the web service client access is yet a third annotation that you can use. So, again, pre-version 3, we had interfaces and the config files. That's optional. Again, you have annotations, and you have something called no interface view styles, which is the simplest kind. Basically, all you need is an annotation, and that's it. So, as I said, local beans are accessible in the same context. All the different kinds of beans can be declared local. And the reason you might ask yourself, why don't you play it safe and make them all remote? Because it will find it locally, even if it is declared as remote, is because there's overhead involved to do that. So from a performance point of view, that's why you don't want to do that, although you could get away with it. And then there's a variant of local called local bean that really has more to do with overriding the default behavior. If you're saying something was, the interface specified it as being remote, and I really want this particular implementation to be local, then you have to use this guy to override it. Remote, again, it's in the same context, though, again, you don't want to do that usually. Or outside. It could be on different machines in different parts of the Usually the way that this is actually supported is by using something which I haven't really gotten into very much, which is JNDI. JNDI, that's a Java naming and directory interface, which you've seen actually a little bit of when you were defining your JDBC connections. Remember it said JDBC : / blah, 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 blah. Those are JNDI strings or paths, okay? And it's actually, it's a very important part of Java EE, but it's kind of a pain in the butt to use, which is why a lot of these annotations and such eliminate the need for you having to use JNDI directly. They may be using them underneath, but you don't necessarily have to know that. It makes it a lot easier. So, let's see. In terms of, what else? Any other known objects? JNDI, by the way, is capable of finding many different kinds of services, not only the session beans and such. You can say, I want this to be, this kind of object to be known in my whole environment, which could span many, many JVMs, many different machines. And JNDI will know how to talk amongst them to find where it actually lives and go get it if it needs it. Only the session beans can be declared this way, using this annotation style. Web service path. Basically what this does is it allows you to very cheaply, very easily create a web service endpoint, okay, without having to do any special configuration. You can simply say this method is now going to respond to every GET request at that URL, okay, and you just have to know how to specify the annotation properly. So that's, when we have time to get back to services, services for us right now are kind of nice to have. You understand basically what they're about, but I haven't shown you any real examples of it. And you're not going to necessarily need them to do anything you're doing, but hopefully I have enough time in the course to actually go back and find some examples of them for you. But this makes them very easy to write. So again, these are the annotations we just talked about. Of course, for JPA entities, that doesn't make sense. Those are all local. Again, these are the two management modes, what they call. Those are how are the transactions managed. Again, annotations. I had shown you an example of these things in at least one case, the first two. I can remember at least one example where I showed you that. By and large, if you're using just the basic EJBs where you have one transaction per method, then you don't actually have to say anything. As you'll notice, most of the time you haven't said anything in the code that you've seen. But if you want to shift over to use the bean style, where you then have more control, but you also have to do more, this is how you would say it. So usually speaking, this is the default, the first one, and you don't have to say anything. If you need that, then you have to say this. That's effectively how you say, I'm doing my own transaction management. Here's another thing, so I'm not going to get into much right now, is this idea of security. There are lots of different ways of doing security in web apps, and we'll talk about that. But this is specifically how you can use EJB to help secure itself. So what this is actually saying is most of the security that you get out of the box in this world is what is called declarative, role-based security. Okay, so the idea is that you have two different kinds of entities. One is the users or the clients, those things. Those guys do what is called authentication. Authentication is proving you are who you say you are. The other word that comes into play is authorization. These are two different things. Authentication, you are who you say you are. Authorization, you can do what you're allowed to do. I know who you are, so these things always go together. the authentication has to happen first so I know who you are. If I don't know who you are, then we never get to the second question, okay? But if you are authenticated, you can be authenticated into a role, okay? You can be a regular user. You can be if you're doing insurance, you can be a claims adjuster. You could be a branch manager. You could be a policy holder. All of those things would be roles, and you could use those to say only if you're a system admin super user can you run this EJB. Can you access it? Okay, so you can get down to a very fine level. Now, I'm not saying that's the way we normally would do security. What I'll show you is something else, which is at a more programmer level security. But you can actually get down into this level if you really want to protect things, no matter who is trying to call it. Okay, so it's a very very low level way of doing protection. So, all right. So in terms of, those are the four basic kinds of EJBs we're talking about. You have some idea now that you have transaction capabilities, there's some security capabilities. So let's look at exactly how they're used, how they're created and destroyed. In other words, what is their life cycle? Essentially, any EJB you use, it may look to you, the program, as if you are have direct control over it, but you don't. Okay, you simply are. When you do an injection or something like that, you're essentially requesting the system, the server, to do something on your behalf. So and that's where this proxy idea comes in. So you're interacting essentially with the proxy, and then the EJB itself, the beans, are controlled completely separately from you. In other words, you can't take an instance and destroy it. You're essentially, you can create it, you can ask, even though it looks to you like you're creating it, you ask that it be created, you say, I'm finished with it, you can do whatever you want. From my point of view as a client, it's destroyed, I don't care. But what happens underneath is separate, okay? So they're created and managed by the container. All that stuff is hidden. So in terms of the three major beans, when does it get created? The first time the client tries to use it, okay? That's a stateless kind. Stateful says on every client lookup it has to, wait a second, is that backwards? Actually, I think I may have written that backwards, now that I think of it. And the singleton is essentially, because there's only one of them, it's when the application is loaded or the first time that it's called. That's actually up to you. You can say, create these things all at once before anybody starts to do anything, which might make sense, rather than let it be created the first time it's actually called for. Now, on the other hand, the destruction, again, is not in your control. You simply do things that allow the instance to be destroyed or from your point of view, it looks like it's gone. Whether it's actually gone or not is different. If it's stateless, it can go back into the pool or become inactive. Stateful, essentially, it can either sort of expire and time out if the client is not using it within a certain amount of time. That helps you from building up a lot of junk. People creating their shopping carts and then going away on vacation for 2 weeks. You don't necessarily want to allow them to leave it hanging around, because then you've got to maintain it somewhere as a server. So you may in fact say, if it hasn't been used in 24 hours, I'm getting rid of it. Sorry, you'll have to start over again. Or you can ask it to be removed specifically. And the singleton, of course, only goes away when the application shuts down. There can be certain exceptions to to cause beans to be destroyed, but hopefully that doesn't happen very often. So what does the life cycle of a session bean look like? Obviously there's when it's created and when it's destroyed, but there's stuff that happens in the middle too. And that's actually, the reason I'm going into this is because it's useful for you to know what those things are, particularly in the case of right after it's constructed and right before it's destroyed, because there might be cases where you want to do things to make sure that you have everything has been set up, and before it goes away, you might want to then release things that you have acquired yourself during the bean's life. So these are what are called phase transitions, when it goes from these different states. And you can actually monitor them and watch for them using annotations. There's one that you may have noticed that I had been using in some of the code that I've shown you, which is called @post_construct. Did you notice that? You might not have known what it was for, but that's a very common one, which I would recommend that you use on all of your beans. And we'll see what that's about, okay? The reason you'd want to do that, by the way, has to do with injection and making sure everything is injected before you run off with your bean and start to use it. Because if you didn't do that, it's conceivable that the injections that you were expecting to have happened aren't finished, and then you start to do things with your bean. So these phases can be monitored, and you can then say, okay, when that's finished, do this, or before that happens, do this. The life cycles are slightly different for each of the different bean types, and then it allows you to essentially, a lot of it has to do with initializing stuff and then, uninitializing, letting things go properly, like database connections or something like that, where you don't want them just floating around open. You want to make sure they get shut down and released properly. That's a reason for this sort of thing. So these are the phases that it goes through. Does not exist. Means the bean that you're referring to doesn't exist yet. Here's the one I was talking about, post-construct. It means that up until this phase becomes active, the bean itself is not ready for you to use, because there might be things that it was doing in its construction, like you did injections of other beans into it, or you injected the entity manager, or all that stuff takes time. And if you didn't do this, if you didn't wait to, let's say, initialize your variables, your instance variables, you could wind up doing them out of order, which could screw you up, okay? So that's why you'll find in a lot of the code, and I've gotten used to doing this now, is when you have a bean, you always have something like @post_construct, a method called, you can call it whatever you want, doesn't make any difference. I always call it init. People seem to use that a lot. So I create a method called init, which is hooked to the post-construct phase, and I know that if this can get, and it will automatically be called for you, you don't have to do anything. You'll know that anything that had to happen before that to create this bean has been done, okay? So it's a safety measure for you. And that's in effect why you see it all the time. People use it that way. Then ready, okay, that's another transition. Now everything is ready for interactions, okay? Now, this is the other end. Before, if the bean is ready to be let go of, you can monitor this phase transition to say, oh, I'm ready, the server is telling you, I'm ready to do something with it, to take it away. If you want to do anything to it, you better do it now. Okay, and so if you had, I don't know, your method hooked onto, some other external service somewhere, and it opened a connection, it opened an RSS feed, or I don't know what the heck it could be doing, but all that's legitimate. But if you wanted to make sure that instead of that connection being left dangling there and timing out, or as a sloppy programming, you might say, oh, before you destroy this, let me go up and clean up after myself first and close all those neatly, okay? And then here's the one other one, and this only makes sense in the sense of stateful session beans. The term activate and passivate, what does that mean? Stateful session beans, of course, can have lifetimes longer than a single call. That's the whole point behind them, right? Those lifetimes can be very long, depending upon how you set your system up. They can be, anything from a couple minutes to hours to days to weeks, whatever you want it to be. So, however, the system needs, instead of building up, hundreds of thousands or millions of these stateful session beans, most of which are now gone dormant, which may still be necessary to keep, okay? The server, the EJB container, has the ability to what's called passivate them, which is a verb I'm sure you've never heard before, but to make them passive. In other words, put them to sleep, essentially, okay? And what it does is it serializes them, which is why you like to make all of your beans serializable. So it writes it out in a textual format, and then it can do whatever it wants with them. It could send them to another machine, it could write them to a database, that holds to disk somewhere. And then if they are ever needed again, if a request comes in for it, then it will activate them. Okay, so that's what allows you to have a stateful bean that can sit around for a week without being used and still be available, but also still not take up memory, okay? Because it has essentially been put to sleep until it's needed, all right? So that's what passivate activate has to do with. So there are certain things that you might want to do when it is put into that sleep state. If your bean, for example, was checking something every so often, then obviously you don't want it to do that because it's now gone to sleep, and so that doesn't make any sense. So you might say, if it's passivated, then do this, okay? And then when it's activated again, then do with something else, okay? So that's the other guy there. Okay, so these are the annotations. These are the 5 important ones. Not all the beans go through all these, as you'll see, but basically this is how it works. Post-construct, that's the one I told you about. Pre-destroy, pre-passivate. In other words, you'll know if the system is ready to put it to sleep, it will let you know so that you can do something first. Post-activate, this is the opposite. It says when it comes back, I want it to now hook itself back up to these other 3 things. And then remove, this is when it really is getting ready to go. Okay, so if you need to track that, you can also track that. So here's the stateless bean. This is the standard life cycle. You create the instance, you do the post construct. So when you create the instance, it may actually do a bunch of other things, like do the injections that you asked for. Then the post construct, this is something you do usually and this is where you would initialize the values of your instance variables, for example. Okay. Then you do your stuff, the business methods, whatever it's supposed to be doing. And then if you need to undo something, again, if you want to be tidy and clean up, then you would have a pre-destroy method, which would then do that. And so you know that when it goes away, it's now tidy about what it had created. Stateful beans, again, same thing, except you also have that passivate activate business. You can also monitor that. Okay. The stateful beans. Okay, so this is the whole setup there. It goes from does not exist to ready. It can go into passivate mode. It can come back to ready. It can go back to passivate mode. It can come ready. It can do it again. It can go ready until remove, which will essentially put it back into does not exist mode. Okay. The singleton beans are more like this, and again, this is like I said before. The singleton beans are more like stateless beans, except it's just one of them. So there's no idea of passivating these guys. So these are the callbacks. You can receive notifications on any of those transitions. You simply have to annotate it with the method. That's all you're doing. You're annotating it to say this particular method is what's going to handle the post construct if I see it, or when I see it, because, well, you'll always see it. So here is a simple example of this. This is a Singleton bean. It's, and basically, it doesn't really show anything special happening, but this is a good idea anyway. The idea is that this guy here, okay, and again, you can call it whatever you want and you can have it do whatever you want. If there's anything special happening before that, and again, you usually see this with injections and things like that, you're sure that whatever it's depending upon has finished, okay? So it's a good idea to have this, even if it does nothing more. Well, actually, that's what it's doing here. It's initializing that guy, okay? So you could say, why isn't that in here? That's what you're used to doing in Java, right? You initialize things in the constructor, okay? That's why, because there's more going on here, because you're living inside of a server. And so there's this whole life cycle that you don't get in just regular Java code. Likewise, so here, this is kind of a simple example of the idea, but so here, essentially what you're doing is calculating how long this thing is alive for, okay? So here you initialize, that's the time here, and then you're going to compute the difference in time, so you can say how long did the bean actually live for. So, I mean, that's a simple, kind of trivial example, but that actually could be useful for performance monitoring purposes. But you can imagine doing a lot of other things like that. Okay? Designing the modern beans, you optionally create the interface definition, then you implement it. Or you can simply implement it with an annotation. There's also this idea of metadata. You can actually use XML configuration for adding a whole bunch of other specifics about the bean, which if the annotation should take precedence over whatever is in here, but if the annotation weren't there, it would still work properly. It would still, you could say this class is a session bean, it's a stateless bean, without using the annotations by putting them into here, okay? You just have to know what the XML format is for defining those things, okay? And so you can always do that. So how do you go about using these? Basically, you define your business logic interface. Again, I like the idea. I mean, the interfaces are kind of cheap. The interfaces in this world got a bad name because there used to be a lot more stuff that you had to do to make the bean accessible. But here, the interface is simply, a couple of methods, and you implement as much as you want in the interface, and you define as much as you want in the interface, and then you implement as much as you need in the implementation class. Then you annotate it, okay, the interface. If you are going to use an interface, then you can annotate the interface. Then you create the implementation class, the thing that's actually the bean that gets created. You annotate that thing, and then you basically use it. Make sure it works, deploy it, test it, use it, blah, blah, yeah. It's basically, if you are going to use the interface, it's just a standard looking Java interface definition. It's public, the term interface, and then you give it a name. Oftentimes you use the word interface in the name too, just to make it clear what it is. As I said, it's no longer mandatory in our case with these beans, but it's still often used by people. And then usually it is annotated, this is the interface, is annotated with the mode that we were talking about before, okay? In recent releases, you don't have to have the full interface anymore. You can simply annotate the class methods, but again, you know, it's a cheap thing to do. Makes it a little clearer. There's no harm in that, I don't think. And you don't have the problems that you used to have with the extra junk you needed. So here's an interface. Okay, you can implement as much as you want inside the interface. But in this case, they're just definitions, as you can see. There's no implementation here. So that's what the interface would look like. It's local. All that means is that if you're going to use this, the beans that you're talking about are all going to be inside the same JVM. You can have a remote version. Now, what I've seen better examples of this where these two things would have inherited from a common interface. So you'd have an interface which then had a local version and a remote version, and then you implement each of those, which I think is a little cleaner myself. But anyway, so this is just two levels. In terms of how you code them, how you implement them, it has to be a top-level class. In other words, it can't be a inherited class. It has to be public, because it has to be able to instantiate it. Okay, otherwise it doesn't make much sense, right? Can't be final or abstract. Again, it's got to be just a normal kind of class. Must have no argument constructor, so it feels just like a JavaBean, the other kind, you know, the vanilla kind. No finalized method. Again, that would get in the way of the beans being managed by the server properly. And of course, if you have a business interface, it has to implement the methods, right? That's the definition of an interface, right? Optional is to have the interface, but at any rate, then you annotate the bean. This is your implementation with one of the types. So here's an example of this in a little bit more detail. Now, it's not actually showing here the code, but there would be code in these braces. So here's the local calculator bean implementing the local calculator. Notice it doesn't have to say local, but it is because it's implementing a local interface. And then each of these would actually be the instantiations of it. Any one of these that were common to local or remote could have been implemented in the interface itself, too. Okay, you see examples of that. And so these things could be very skinny at this level, unless you need to override it. Here's a remote version, okay? And notice you don't say @remote because you're implementing a remote interface, okay? Same thing here with the Singleton. Now this in fact, you see where it says, it's a little hard to see because I didn't take this screenshot, but before the word Singleton is @local bean above it. This is where you would use that, because essentially it's implementing the remote version of the interface, and yet they want it to be local. Okay, in order to make that work, that's where local bean comes in, because effectively you're saying you're overriding the remote. Another thing that you can do is you can define when the bean actually starts up. Here, this is a little more interesting. The thing is that when does it actually get created? I mean, it's not literally when the application starts unless you say that. You could, there are two different kinds. Remember we said this about the JPA too. When do you read in the rows from the database? You can either do it in a lazy way, which says, don't give me all 100,000, I'm going to ask for them 100 at a time. That would be what you would call lazy. And then eager, which in this case what that means is the first time anybody asks for it, maybe nothing in your code asks for it except once in a while, don't waste time creating it. The first time it's needed, it will be created. Versus eager, which you can specify with the startup annotation, which says, look, come on, let's just create it and then leave it there until somebody needs it. I would think most of the time that's what you'd want. but I guess it depends, exactly what the circumstance is. I could invent something that says it should really be lazy, but I don't know. But anyway, another thing that the Singleton can do, there are annotations to say that you can have many Singleton beans. All right, it's just each one is its own thing. However, you might say that in order for me to create this Singleton bean, it depends upon the other one already existing to make it make sense, okay, or to allow it to be initialized properly. And that's where this depends on annotation. So if you ever have that kind of consideration, you can actually use that to say, in this case, if the question is which Singleton is created first, the answer is going to be the first one, because it says class C, and then the second one depends on C, the third one depends upon B, so the order has to be C, B, A for this, okay? But it could have been ABC or BAC, depending upon how your depends on were specified, okay? Anyway, just a little side thing, but you may need that. The instance is, again, created and managed by the container, hidden from the client. It's all through a proxy. The client can be any number of things. This is just a quickie little review. Can be an application, standalone application client. It could have been an applet, some other component inside the web container, any Java applet or I'm sorry, object, or any kind of Java application. And so the what's actually happening is the proxy, in order to find what it's using, what it needs to use, is going to use either JIND, okay, that mechanism to find it, or it's going to use dependency injection, which is the way that you would normally see it. So again, that's what that picture shows. So in terms of interacting with an EJB, you would typically declare some reference to it. You would get the instance, usually using, in our case, dependency injection. That's when you say @inject. That's what this is doing here. And then you invoke the methods. So that's the loose coupling that you're getting from dependency injection. Again, that was something that was added to Java EE over time. It wasn't there in the beginning. Became very popular, and in the meantime, Spring was also interested in using it. And actually, a whole bunch of people, the Spring people, the Java EE people, got together to define the CDI interface that you know. Okay, it's all annotation based, as you saw, and it makes using JIND transparent, basically, which, believe me, is a nice thing. It makes your life simpler, a lot simpler. So the CDI removes those lookups. You can use it to do this injection, and effectively all of these annotations that you see here, @EJB says I want to use, I'll use that term first. I want to use this EJB, which would be some stateless, stateful Singleton bean that you define someplace else, here, okay, in this method, in this class. Resource, there are a couple of things that are considered resources, like JMS entities, not entities, objects, or some are called resources. The other two, persistence context and entity manager, you of course now know from JPA. But in fact, even though this is typically what you use to actually do this, but effectively what you're doing is dependency injection underneath. The container is actually looking up and then inserts the references for you based upon the defaults. Okay, so if you're trying to do an entity manager, it will know to look for entity manager things that have been created by JPA, and then you can get access to them without having to know anything else about it. You can override, even though I haven't shown you many of the annotations, most of them take arguments, optional arguments. Okay, I mean, which you can look up. They're only used in particular cases. Well, actually, you saw it, like inject. What is it for CDI? Value equals blah blah. Okay, like that kind of thing. If you look up the Java docs, you can actually see there are usually more kinds of things for special cases. CDI nowadays is actually available in virtually everything inside of Java EE. It is everything. You can even use it with Tomcat, for example. You might have to load your own CDI library, which is basically the same one that Java EE uses, but you can use it in there too if you want. Oh, and the other point with CDI, of course, remember what I said. JSF had this concept. There was a lot of this floating through the development world. This idea, JSF. This is where the @ manage bean comes in. That was JSF's version of this, doing this, okay? That's why I try not to get you not to use that anymore, because it's eventually going away, because everybody has now said, well, CDI should really be doing that, so there's no reason JSF has to do that anymore. Okay, let's see, what else? I'm gonna try to get to the end here before we break. Just to be specific about these things, @ EJB does dependency injection for beans, session beans and such. The resource, it's used for dependency injection of things that are not EJBs, specifically things like if you want the session context, that's something that you would get if you really if you really want to handle on the session information. This is how you would get it. You'd essentially ask CDI to give you a reference to the session context object, and from there you can get lots of information about the requests at a very low level, the responses at a very low level, everything like that. Or data source, which is the JDBC stuff. Okay, if you need access to that, you can ask using @ resource for a reference to that stuff too. A lot of times you don't need to do that anymore, but you can if you need to. So how does it work? It's based upon context. You basically use defaults, and unless you have something special, it can usually figure out exactly what thing you're referring to. There are ways of getting beyond the defaults, but generally speaking, in our case, I don't think there's anything that you would do where that's really necessary. So it's usually very simple. You can either use @ EJB if it's a session bean, or you remember I showed you how to wire beans together in that example. That's an example of using inject directly, @ inject. Okay, to take one entity. I'm sorry, I don't mean to use that term because that sounds like JPA. One object reference and make it available to inside of another. Okay, then you can use the native @ inject, which is kind of the least common denominator for this. You can actually, by the way, you could actually do @ inject of session beans too, to be proper about it. That's a fairly new thing. But for our case, it's better to make it clear so you know what it is you're referring to. So here's an example of, see, you can even do this inside of a servlet. Okay, so if you needed to, if you wanted to process, this is sort of outside of JSF. If you wanted to process an incoming request yourself, like you might do for a web service, where there's no JSF involved, you're simply getting a request and you're going to be sending back some piece of data, then you can actually inject an EJB, one of your business logic objects, right into your servlet too. So it's very flexible that way. One last thing I wanted to go through, because it might have seemed odd when you did your simple. I think that's the one that you saw. Actually, you saw it in the simple EE6 app and you also saw it in the CRUD one. Okay, you saw this idea of facade. This word kept coming up. So I just wanted to very quickly explain what that was and where it's coming from. The facade pattern is there are many different kinds of patterns. All right, I don't know if you've ever studied patterns in doing programming, but that whole concept, particularly in the object-oriented world, has become very popular and very important. The idea of patterns actually comes not from programming. It came originally from architecture. Christopher Alexander, who's an architect, basically came up with this idea of saying, look, you know, I'm an architect. People need to get inside of things. So we have the concept of a door, right? You know, how many times do you have to reinvent the door? No, I mean, it may look different. It could be rectangular, it could be triangular, it could be round, if you're a hobbit, let's say, you know, etc. But the concept, in other words, there's a problem that needs to be solved. Okay, there's a context that the problem lives in, and then there are commonly accepted, well-known solutions for this problem. Okay, that's in a nutshell is what a pattern is. So when he first came up with it, he was talking about buildings and such. Okay, but the whole idea has been taken over by the computer, you know, software world, and so you might have come across the famous gang of five. I forget how many there are. 4? Yeah, Gang of 4 book, the Gamma book, and other things like that, which describe programming patterns at different levels. Okay, from very low level, you know, kind of like the class and that coding level, all the way up to architectural levels, which would be, you know, how do you put systems together at a much higher level? But it's all the same idea. Okay. There's a context, there's a problem, there's a set of solutions, a pattern. This one is one of those. Okay, if you look up there was something which you can still see, which was called I guess it was called the J2EE blueprints. Okay, which are a set of architectural patterns for systems. One of them is called the session facade, and all this is. The idea is you've got some low-level stuff that you need to do to achieve whatever it is you're trying to do. However, that's not what you want to show to your user, okay, of your code. You want to show them something easy to understand, simple, straightforward, something that's flexible, you know, something that doesn't change wildly. A standard interface. Okay, so they don't have to know what's going on underneath. That's what a session facade is doing. Okay, and so that's why you see them. If you look inside those examples, you could have had your code dealing directly with the entities itself, you know, or the JSF dealing directly with the entities. There's nothing stopping you from doing that, but that's a bad design. Okay, because that will get you in trouble pretty quickly if anything changes underneath. So what you do is, instead of knowing exactly how a user is retrieved out of that particular database, that's what the entity is supposed to take care of, what you do is you write a facade. In English, that means, you know, this is me, this is a facade in front of me. You know, it's like a screen or a curtain or something like that, and then I only expose what I want you to see. So, and that's why you see it all over the place, because it's a good idea to use these things. And that's essentially what you were coding. So now, maybe, hopefully this will make a little more sense why those things appeared. When you did the CRUD application, you noticed that NetBeans created them for you, right? You know, you were dealing with the database underneath, and then you said, okay, now make entities out of this, and then make these other things out of it. The other things were these. So I just wanted to clarify, you may have wondered, where the heck, what is this? Why is this important? So basically the idea is if you want to make a bigger system easier to manage, you make it out of subsystems, each of which reduces the complexity of the whole thing, all right? And the idea, again, this is at a system level. The decoupling I was talking about before was at an object level. You know, the injection stuff, that's at an object level. This is at a system level. We're decoupling whole pieces of the system from each other by doing this. Okay? So that's why you might call this an architectural pattern or a system pattern versus the other one, which might be an object pattern. But it's the same concept. So that's the basic idea. So, and actually you do this all the time, though you don't think about it. So here's an example. In the real world. You know, you order something from a catalog, you call up an 800 number, and you speak with a customer service rep, and they act as the facade. In other words, you're not going into their database in their system to find something. You say, I'm looking for, you know, dress size 14, you know, with short sleeves, blah, blah, blah. So that's the interface that they present to you. However, then they are the ones who know how to actually access, literally in this case, access their systems in order to be able to figure out how to respond to you. Okay? So you see what I mean? That should make it easy to understand why this is a good idea. Because you don't want every single customer to have to know how to do that with their system. So, same idea. So this is the pattern. We see it in the EJBs. The facade is typically a session bean of some kind. Commonly, it's a stateless bean, okay, because it'll do one thing, and, you know, respond to the request, and then go away. But it doesn't have to be. It could be stateful, too. But the whole idea is it hides the functionality underneath. Could be local or remote. You know, and the whole idea is to, again, make it easier to use. You create the facade interface, which is what NetBeans did for you. You expose just a limited number of methods, not everything underneath that they don't need to know about, particularly exception handling and stuff like that. You create a bean based upon that. Could be using other beans to do what it needs to do. Often, and it's all wrapped in a single method for convenience sake. And then you handle all of the ugly stuff underneath, all of the exceptions, in some nice client, as you say, client-neutral way. In other words, so that you don't have to know, oh, that was an MS SQL Server error versus an Oracle error versus, you know, a MongoDB error or whatever the heck. You know, you just say it's this, you know, user not found exception or something like that. So here's an example. This is this actually goes with this next thing here. This is the delegate. Sometimes you'll hear that term. So here, this is a stateless session bean. This is the facade. It's going to implement this other thing. It's going to inject this delegate here. It's going to get, oh, here's an example of the session context I was talking about. It's going to inject a resource. That's a session context. Then this only has two methods in it. One is, to print out something to the log, and the other thing is simply to return the message that's being requested. And here is the delegate that is the implementation of that thing. Again, so you can essentially hide everything underneath using this facade. And anyway, so I just wanted to make sure that we wrapped it up with that because I thought that might be confusing to you why those things existed. You'll hear them, or similar things, you might hear of two other patterns which are similar. The data access object, okay, that's essentially, the way I think of that in our world is more like an entity bean. Not an entity bean, but the JPA entities essentially are like data access objects. And then DTOs, which are data transfer objects, sometimes you'll see those act as simply a a standardized way of passing information around inside of your system. Okay? So, you know, in the systems that we're writing, that's probably overkill. But if you're going to be writing much more complex systems, then you might have another kind of being which is simply acting as like a holder, almost like like a manage bean kind of thing. Acts as a holder for the basic information. So if anybody wants to know about a user, they go and get one of these things. However, that thing doesn't actually do anything per se. It simply just represents this object type, a particular instance of this object type. So that might be a data transfer object, in case you run across those terms. Okay? Any questions? Hopefully, did that help? I don't know if did anybody feel confused? Because I know that, no. Well, hopefully you're not. You may have been confused before, I don't know. But you're not confused anymore, I hope, right? No? Right. Did you find that helpful? Okay, good. Because I know that's, I always found that difficult to kind of grasp how everything fit together. Part of it always seemed like magic, but hopefully that makes it pretty straightforward. Now you actually have, I think, everything you need to build a pretty sophisticated system on the server side. There's more stuff we have to do, but that should give you enough to build the business logic, talk to the database, do some JSF so you can develop an interface. So you have enough guts to get going, okay? So we'll see next week how far you've gotten. Anyway, okay, so let's take our break, and we'll be back shortly, and we'll get in. I'll stop with the very technical stuff and start to talk a little bit about